In this video, we're going to look at a couple of different common problems with combined functions. The first one here just turns out to be fairly straightforward practice. Now, we need to show that f of g of x is equal to g of f of x for each of these. Okay, I'll do an example, chance for you to do your turn, and then I've got some which build in increasing difficulty for you to practice with. First thing we need to do is find f of g of x. Remember what this means is we're going to start with g of x, which we know is 6x plus 5. And we're going to use this as our input for the function f. And that just means when we've got x here, we're going to substitute in 6x plus 5 instead. So we've got 3 open brackets, 6x plus 5, close brackets, plus 2. And we need to tidy this up, so we'll expand the bracket. So we've got 3 times 6x, 3 times 5, still got this plus 2 on the end. We can then add together the 15 and the 2 to get 18x plus 17. So we've found what f of g of x is. Now we need to find g of f of x. So we're going to start off with the function f. You don't have to rewrite it, but I find it can be useful for just getting your head in the right place for the question. So we'll use this output for the input of our function g. Well, where does that come from? 3x plus 2. So where we've got x here, we're going to replace that with our input here. And again, we'll expand those brackets. And finish by tidying that up. And you can see again we've got 18x plus 17, so we've shown that f of g of x is equal to g of f of x. Pause the video and have a try with this one. So for f of g of x, starting with g of x, remember we always start with the function that's just to the left of the brackets with our variable in. And we're going to use that as our input for the second function. So where we've got x here, we're going to replace that with our input. And then we'll expand it and we'll tidy it up. Now going the other way around with this, g of f of x. So starting with our function f, and we're going to use this as our input for g of x. So where we've got x here, we're just going to replace that with this input. Tidy it up. Remember this plus 4 on the end here. And so again, we get 52x plus 17. We've shown that f of g of x here is equal to g of f of x here. I'll put a copy of this in Show My Homework as well. We've done the first two as the example and the Your Turn one. Work through the others. Now they are increasingly difficult because of the kind of values in there, using fractions, using negatives. It is good practice to do this. Now, once you've done that, if you want a challenging extension, it's asking you here in general terms. If we think of f of x as a times x plus b and g of x as c times x plus d, where a, b, c and d are constants, so just numbers, looking for the relationship between those four digits. Okay, so if you want an extension, that's quite an interesting area to explore. So pause the video, have a try with these. Answers will be on Show My Homework. I'll also put them up on the next slide here, just in case that's useful. The second type of problem I want to look at is a bit more complicated. So we've got f of x here, and we can see that's equal to 2x plus a. So plus a constant, a number we don't know what it is at the moment. G of x is equal to ax plus 3. Now, these values of a in this question, they're going to be the same value. And we're told that f of g of x is 10x plus b, another constant. So we need to work out the values of a and b. What we're going to do first is work out f of g of x. Because once we know this, we can say, well, it's got to be equal to this. We can form an equation, we can solve it to find a and b. So as before, we start off with the function nearest the variable, nearest the bracket. So we've got g of x, which is ax plus 3. And that's the input we'll use for our second function. So where we've got x up here, we're just going to replace it with ax plus 3. We need to expand the brackets. And remember, we've got that plus a on the end. So there's different ways we can rearrange this. But let's say we know that's what f of g of x is, which is also equal to this. So let's set up our equation. And then we might want to rearrange this expression we were looking at here to help us do this. That's plus 6 plus a. Now, we've got 10 lots of x plus b equal 2a lots of x. So 10 has got to equal 2a. So a has got to equal 5. That leaves us with b has got to be equal to 6 plus a. Now we've just worked out that a is 5, so b has got to be equal to 11. And that's quite a nice way we can find out the values of both of those. But let's check it works before we go any further. So I'll do that up at the top here. So we think that a is 5. Which, when we've substituted it in to both these functions, gives us these here. Now, if we check f of g of x, so we're taking g of x and we're substituting it into f of x. So 2 times 5x, 2 times 3, that gives us 10x plus 11. So checking this against what we're given here, we've got 10x, yeah, plus 11, so that's the value of b. So we've checked that both these values are correct. This one's really similar. Again, follow through the same steps, pause it, and then check it. So again, the first thing we're going to do is find f of g of x, because then we know that's going to be equal to this. So we can form an equation with those being equal. We can solve it and find out the values for d and e. So g of x we know is equal to ex, take away 1. So that's going to be our input for the function f. And so we'll just substitute that in place of the e here. So we've got d open brackets ex minus 1 minus e. Again, we can expand these brackets, dex minus d minus e. So that's f of g of x, which we're told is equal to 18x minus 11. So again, we can form our equation and go on to solve it. Now we can see here we've got 18x on this side, dex on this side. So we know from this, D times E has got to equal 18. And we also know from here that minus D minus C is equal to minus 11. Now there's different ways we can go about solving it, but I think just thinking through the pair of numbers that will make both of these correct, a bit like how we do for factorising, is probably the most straightforward way to do it. So pairs of factors of 18, so it could be 1 and 18, or it could be 2 and 9, or it could be 3 and 6. And in these questions, in this question, the answer is integers, they are whole numbers. So we can think about which of these pairs will also hold here. And so if it's 2 and 9, so we've got minus 2, minus 9, yep, that works, okay? Or the other way around. So D is equal to 9 and E is equal to 2, or E is equal to 2 and D is equal to 9. Both values work in here. And I've just jumped ahead and shown it down the bottom for both of these. So the first check I've done here is when D is equal to 9 and E is equal to 2. I just substituted them into our functions at the top. Calculated f of g of x and it comes out to 18x take away 11, which is just what we had here. I've also done that here where D is 2 and E is equal to 9, and you can see again, doesn't matter which way around those values are, we get to the same answer here. So again, the example was the first one, the your turn was the second one. 4 more questions to do here, which do increase in challenge. So it's really useful to work through from number 3 and practice your skills with these. Again, this task and the answers will be on Show My Homework, but I'll also have the answers on the next slide here if it's easier just to pause it and check it afterwards. Good luck with these. So here's the answers for this second task. Hopefully they got you thinking, but hopefully you managed to work your way through those okay.